the channel. Let's solve Leetcode problem 1929, concatenation of array. I'm actually not even going to read their description because I think it's a little bit convoluted. So I'm actually going to just summarize it as I would. So the problem, given an input array nums, return a concatenated version of the array. It's super helpful with Leetcode problems to jump right into an example. So the input 3, the output is going to be the initial array, and then in order we're going to concatenate the values again. 3. So once again, it's just the initial array, and then you concatenate the values in order. So the approach we're going to take to solving this problem is going to be nested for loops. We are going to have an outer for loop that is going to be range 2. This is just going to make 2 iterations because we're going to iterate through the input array twice. And then the inner for loop is going to iterate through the length of the input array and add that value to the output array. So we're going to have an outer for loop that's going to run twice, and we're going to have an inner for loop that's going to iterate through each number of the input array. So output array, this is going to be the outer for loop for I in range 2. This is basically going to have 2 iterations. And inside of this for loop, we're going to iterate, I'll change this to J. Actually, I'll change this to J. For J in range len nums. Output dot append nums I. Okay. So what's really going on here? For this outer for loop, we're basically saying we want to iterate twice. And then on this inner for loop, we want to iterate through the length of the input array. And then here we have the output array. We're using the append method. And then we're taking the input array, and then we're finding the index of the iteration we're on. So this actually should be J, and we're adding it. So let me walk through a clean example with let me do a little test case with an input array. So nums equals 1, 2, 3. Output equals nothing yet. J or I is going to equal 0. and then we're actually going to put the j value up here just so we can see what we're looking at. And then, yeah. Okay. So for I in range 2, so I is 0, we want to iterate through the length of the array nums. For the first action we're doing here, we're appending the first value. So nums of 0 is going to be 1, so we're appending the 1 value. And then we're continuing. So this inner loop, for loop, needs to fully execute before the outer loop basically goes on to the next iteration. So this works very nicely because we input the 1, we're going to append the 2, we're going to append the 3, and then this for loop has completed. So then it goes back up to this outer for loop, and I is going to be moved to 1. But then we reset, and we have to do this inner for loop again. So we're going to append the 1, append the 2, and then append the 3. And then when I is 1, this completes. This has done its 2 iterations, and we're returning the output that's outside of this kind of initial for loop here. So let's talk about the time and space complexity here. So time. In this problem, we are going to be iterating through the length of the array of the input array times 2, because we're basically going through this twice to add every number. So we are going to iterate through the input array twice. So technically, this is going to be big O of 2n. But when thinking of time complexity for algorithms, we typically drop constants because we like to think about if the input gets really, 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 really large, and that constant value actually becomes like a non-factor. So we really just turn this into big O of n. This would be a linear time complexity algorithm. In space, a similar idea. We're going to have an output array is going to be 2n, right? So it's 2 times the size of the input array. But once again, as we talked about above, we typically drop constants when thinking about time and space because we think about the algorithm scaling to larger numbers, and these constants become a non-factor. So it turns into big O of n. So the output array, we're creating a new data structure here that's going to contain the length of the array, well 2 times the length of the array, but minimized to n being the length of array. So that is the time and space complexity here. Let's run it to make sure it works. Green there, and it worked. So thank you for watching, and hope to see you next time.